Good afternoon, pilot teachers and students. Good afternoon, class. All right, thank you. You may sit down. All right, our topic for today will be also on electricity, and the subtopic will be voltage or cells in circuits. All right, what are those two different circuits that we have learned? All right, they are parallel and series circuits. So what you will be doing now is to go through and then put those cells or arrange these cells, especially in series circuit and also parallel circuit, and then you come up with your conclusion later on. So we will not waste time. I will now ask each one of the group members to come up, collect the connecting wires, and then you can start connecting the cells, especially in series and so on. But before you do that, I will give you the diagrams that you will need to follow in order to perform that experiment. So the first one is right to measure the voltage of different arrangements of cell. Let us consider the following diagrams. Now that is a statement. Now let's have a look at the, all right, if you want to, you can copy this statement, and then I'll give you a diagram of each one of these. All right, so the pilot students, you can also go through. If you want to copy that information, you can also copy that, and then I will give you each one of those diagrams later on. Right here is the first diagram. Okay, that is how you can connect the cells. How many cells can you see in that diagram? All right, basically you'll find two cells, and then you can measure the voltage of those two cells. All right, so quickly have the diagram. Okay, draw the diagram nicely if you want to, but otherwise just make a sketch of that diagram, and then I'll give you diagram too. Then we can start on the experiment. Right here is the second sketch. Right, that is number 2. Okay, how many cells can you find in that diagram?
1.
Okay, very good. You find only one. here is the third diagram. All right, for diagram C, how many cells can you find in there? All right, there are two. How are they connected? Right, they are connected in parallel. Okay, that is for C. Right, so those are the three diagrams that you sketch. What you can do is to follow those diagrams and then connect the dry cells. And then using that voltmeter, you can measure the potential difference or the voltage of each one of those cells or the arrangement of cells. All right, you can form one group. How that with this can form one group, and then those loads at the back can form another. For those of you who are here can use it. The rest of you can use that one. All right, on the desk you'll find that there is a switch as well as a circuit board and also two dry cells. Right, following the diagram, you can now go through, arrange those cells, and then measure the voltage. You are given the components like the lamps. Right, some others will have a connecting wire to the ammeters, rather the voltmeters, and also the terminals of the dry cell. So you can go straight to measure the voltage of different arrangements of cell given from those diagrams. Okay, the connecting wires are here. Maybe each one of the group members can come up and then collect the connecting wires and also the connectors and those switch boards. Okay, this one does not require a switch board. You just go straight, then you measure. Yeah, the connecting wires are there. Okay, start arranging those. Yeah, they should be always connected to the. Okay, these ones are connected in series. Anyway, if you want to, you can go through it and connect, but it should be connected in parallel with the component. That's right, to measure this voltage of this. Yeah. Arrangement of the cell, only the cell. But if you are trying to measure how much is given to each of these, then we can connect that. All right, listen. All right, you know quite well that voltmeters must be always connected in, okay, to any component. That is, they must be connected in parallel with any component. But this time you are trying to measure the arrangement of cell. So that means you can just connect it straight. You got a switch there. Connect the switch and then you can. Yeah. Got a switch. Yeah. Try to connect the switch and then. All right. Mark, you and John, can you bring this one over here? Okay. Yeah. Come over here so that you can. Okay. Put that over there. Or two of you can come over and then with this one give it to those. Did it give you any reading? Not yet. And then you try the terminals of that to see. Okay, move that around. Yeah. Okay, what is this now in? Okay, the board is here. Let me see. That's right, this one is in series. Okay. Okay, just, yeah, you do only A and B. But make sure you take the reading of that. Okay, you go through and then you check this one. You will be the one to. Okay. Okay. Let me see. No. Okay, I have only this one. I forgot to get one of these again so that you can connect that in parallel. What did you find from that?
In a parallel circuit that has two cells
Uh-huh.
in one cell,
So it is about 1.5.
1.5
And then 1.5. Two cells in series. So why does this?
it has many it has no pathways for electricity to flow, so it divides the electricity.
All right. All right, those are the two questions that for that activity. Question number one is what are the voltmeter reading for the circuits that you have connected? Okay, remember the first one was two cells in series, and then you have only one cell in series, and then two cells in parallel. And question number two is how would the method of rather connecting the cells in the diagram affect the terminal voltage? All right, let's, that group there, you finished? Not yet, you are still going through. Okay, I'll give you some time to quickly do that.
The voltage is same. The voltage is same. Same.
Same in? Okay, which, where? This one is? Okay, you explain what you think. What about this one? This group, what was your first reading?
For the single dry cell it was 1.4 volts. For the two dry cells in a series it was 2.8, and for two dry cells in parallel it was 1.4 divided.
Okay, so you have two in series was double. Okay, it was doubled, but in parallel and one cell in series, or half of that. All right, okay. You explain why you think this happens. Okay. Okay, I forgot to get one of these. So anyway, you, yeah. let me see the connection of the circuit. Okay, that is two in, three of them in, two of them in series and the other one is in. Okay, two cells parallel.
Series but connected parallel.
Okay, so what?
What we did, we came out from connected
Uh-huh.
to there, and then from here we come in over here,
Okay,
and from here we go to there,
that's right.
and this one goes to there.
Okay, okay. Okay. Um, you will start first. We'll move down this way. Probably you'll give the. Okay, what are the readings for each one of those circuits or the arrangement of the cell? That is 1, 2. Then we come over this side and finally to the last one. Can you just give us the reading and then you explain why the or how the method of connecting that is affecting the terminal voltage? Okay. You ready? You ready? Okay, I'll give you 5 more minutes and then you will start. You finish? You got your readings already? What is for your what are the readings that you got from the
First reading was 2.94.
uh-huh.
Second reading was 1.5.
Uh-huh.
1.45,
Mm-hmm.
and the last reading was also 1.45.
4, 5. Okay, good. So what do you think? What do you think happens? Because it decreases when you connect. Okay, why? Why? Okay, looking at that, why do you think this one is 1.4 if you're connecting that in parallel? This time you have 2, but when you have 2 in series, why does it give you 3? Or is it 2.8?
1.4.
All right, for those students, the question is, why does the arrangement of cell, especially when it is in series, gives you a larger size, but when it is in parallel, this time you have only 2, but it gives you less. Why does this happen? All right, maybe we'll go through the questions now. Let's say the first one, that is, what are the voltmeter readings for the first arrangement, second and the third arrangement of cell? So I will now ask the first group, that is Nathaniel and Isaac. Solomon, your group will tell us or give us the reading of the voltmeter of the different arrangement of the cell.
The reading for the 3 circuits, circuit A was 3 volts. In the circuit B and C, we
B will be
1.5 volts.
1.5 and C is
Same 1.5.
1.5. All right, question. What do you think the arrangement of cell has to affect the terminal voltage of the circuit or the cell? Can somebody explain that question? All right, question is here. How would the method of connecting the cell affect the terminal voltage? All right, we are still on the first group. Okay. The next person can answer question number 2.
For number 2, our explanation would be if 2 cells are connected in parallel, the sum of their voltage will be divided by their average, which is 2. So therefore, we got 1.5 volts.
All right, that is his explanation of connecting 2 cells in parallel. When you have to add that in, let's say you connect that in a series, they add up, meaning that one of these cells will be 1.5 and then the other will be also 1.5. So that gives you a terminal voltage of 3. Or if you measure that to be 1.4, it will be 2.8. Now in a series, as what he is saying, it has to divide. Okay, so that is the average. Okay, average of the 2 cells will give you 1.5. Okay, we'll get the answer from group number 2. What is your reading, or what are the readings that you have for that arrangement of cell? All right, arrangement A will be, okay, you can go through and then mention each one of those.
The reading from the first voltage is 2.8,
It's 2.8 for the first one. That is arrangement
and the
A.
second, and the second one is 1.4 in the series. It's the second one. It's 1.
All right, this one is in series, and that is
1.4.
1.4.
And the third one is 1.4 in parallel.
And this one, the cell are arranged in parallel, but they give you 1.4. All right, so okay, that is quite correct. Now, explain why this happened. Question number 2. Okay, somebody from your own group can answer that question. Only you want to answer. Okay.
Okay, because the circuit is in series, the current flowing in and going out is the same throughout the series.
But is it the current or the voltage?
Yeah, the voltage is the same. but in a parallel circuit, it has a branch. That's why the current breaks up and then go to the different branches. But when they come to the point, the finishing point, the current, the voltage remain the same.
Okay, very good. So you have different branches of that circuit because it is parallel. You have two different branches. So what happens is the voltage coming in from one of the tri-cell, and then another one coming. So what happens is they have to separate. Okay, it can't get the other pathway while the other voltage should be getting another pathway. So that is why we have to have only 1.5. It is half. Okay. Okay, let's have that group. All right, just give us the reading, whether you agree with this group or their reading.
First one, for A, we got 3 volts.
All right, this one is
3 volts.
3 volts. And then second,
1.5.
1.5.
And the
And
last
the
one
third one
was also 1.5.
is 1.5. Okay.
That's
Explain why you
because,
got this.
in a
readings.
series circuit, the voltage from the cells would come together, and in the one wire would be concentrated. And in a parallel circuit with 2 cells, the voltage is divided into half the size of the total voltage because the cells are connected separately.
All right. So in parallel circuit, you have the voltage which divides. And for series circuit, if you have 2, right, that will add up to give you a total, which is 1.5, and also 1.5 will give you 3 volts. Right, finally, moving on to the last question, or last group. What is your reading from that? Those.
For question 1, our circuit with the 2 cells, we got a reading of 2.8 volts. And B,
2.8.
the one with a single cell, we got a reading of 1.45 volts. And C, the battery connected in series with parallel to the voltmeter, we got a reading of 1.45 volts.
All right, explain why.
When you have 2 cells connected in series, power is concentrated onto one line, so one circuit. So it's like the voltage is 1.5 plus 1.5, which will be 3 volts around. But when you have a 2 cells connected in parallel, the voltage decreases because both of them, the 1.5 volts are being, 3 volts, both of them equal 3 volts, but they are being, what should I say, the line is being, the current flowing around the circuit would have to be 1.5 because you are getting the 3 volts and you are dividing by the 2 cells there.
All right, good. All of your answers are quite correct, and from that experiment you did, all right, all of you got the same answer for the reading and also how you arrange the cells, especially in those circuits, whether it is series or parallel. Right, in here, quickly to summarize what you did, especially when you are connecting the cells this way. All right, this one will add up with this because they will be flowing in only one loop or one circuit. That is why this cell voltage will add to this second one to give you 3 volts. Right? If you have to connect only one, then it will be 3 minus 1.5 because one of these cells will have 1.5 volt. But this time, if you have to connect the the cell in parallel, you find that okay, this is 1.5 that is coming in this way, and then you have another 1.5 which is flowing that loop. But when they come when they come over here, we will find that whether one of these will be moving because there are different loops that are formed when you connect that to or arrange the cell in parallel. So that is why we only have about 1.5 which is given from this loop here or the circuit. So that is what you should understand whenever you are connecting or arranging the cell, especially in a dry cell, or rather a circuit, which is either a parallel circuit or series circuit. You will find that the terminal voltage will be changing. Okay, series it may increase if you have to connect one after the other, but if you decide to connect that in parallel circuit, if it is 1.5, whether you connect 3 or 4, it will still give you a reading which is almost equal to only one cell. Right, so right, that brings us to the end of our lesson. Our key phrase will be our key phrase will be voltage of cell in circuits. Right, once again, good afternoon, pilot teachers and students. Good afternoon, class. Good afternoon, Mr. All right, thank you. You may sit.